Good morning guys, Anjani Kumar here, dealing instrumentation subject for a final year electrical students. Right, in a last session we discussed about selection factor while choosing your transducer. Right, I'll just briefly remind those things that what we did in the last session. So basically, if you want to choose your transducer, there must be a selection factors. So with that, if you use those type of a transducer, that will be very helpful, very useful to get accurate results in our circuit. Alright, so there are several selection factor will be there for a selection of a transducer. Those are, the first thing is based on operating principle. That means whatever the principle that are established in our circuits. So with that you have to choose your transducer, right? I'll remind you guys, and after that sensitivity. So whatever the transducer that you require, which is having a high sensitive, right? High sensitive means for a small disturbances also it can be detected, right? And after that, third one is accuracy. Alright, the degree of closeness from measured value to the true value, we can call it as a accuracy. So each and every transducer that what you are going to choose, which is having high accuracy. And the fourth one is loading effect. So each and every transducer what you are choosing, so that have a less loading effect. So what is the condition or what is the parameters for a less loading effect? High input impedance and low output impedance. Right? This is a loading effect. And the fifth one is error. So definitely whatever the transducer that you are going to choose, that must have a less error coefficient. The loss of errors are very less, then only you will get accurate results, right? After that, climatic condition, environment condition. So whatever the transducer that you are going to choose doesn't vary with the climatic condition like humidity, temperature, and static electric field, static magnetic field. So these are the climatic changes. So whatever the transducer that's not depends on those environmental conditions, right? So those type of transducer that you are going to choose for your operation, right? So after that, second one is operating range. So whatever the transducer that you are going to choose must have a high operating range. So with that, with the help of transducer, you just do for a number of operations, right? So and the resolution of this transducer also will be very high, right? So that's one of the property. And eighth one is wire communications, right? So whatever the transducer that you are going to choose doesn't depends on external communication signals, right? It doesn't depends on external communication signals like other frequency signals. It doesn't disturb the output value. Alright, so that is one more property, one more selection factor that you are going to choose. And after the ninth one is cross sensitivity. Cross sensitivity means it is used in a mechanical transducer system. In a mechanical transducer system, you can easily direct without a transducer. You can easily convert a non-electrical quantity into electrical quantity. Right? So you will get the result. So that is separated. After that, you will do the experiment with the help of a transducer and find out the result. So you just compare. So that must be equal. So those type of transducer you should require. So that is called a cross sensitive. You are crossly checking, so which is giving theoretical and practical results are the same. So then those type of a transducer that you are going to use in your circuit. So these are the selection factor while choosing your transducer. Very, very important question. Choosing transducer. Right. These are the 10 selection factor you are going to choose while taking. So which type of transducer is suitable for our circuit, for our operation, in order to get the better result. Right. And today we are going to deal about what is the advantages of a transducer. Very, very important. So not that much important, you just need to know, about the advantages. Right, non-electrical quantity is converted to electrical quantity is a better advantage. So with the help of electrical signal, you are going to operate number of instruments, number of components, number of systems, number of computers, right? So you are going to operate, so that's electrical signal is most advantageous than any other signal, right? We'll discuss about the advantages. So in this session we are going to deal about the advantage of transducers and basic types of a transducer. In the next session we'll discuss about each and every transducers with neat explanation and example orientation. Right? First we discuss about the advantages of a transducer. So why you are calling electrical transducer means we require electrical supply. So transducer is nothing but it converts one form of energy to another form of energy. So non-electrical quantity converted to electrical quantity. So you are converting electrical energy. That means it should be useful for our daily life. That's why we are taking electrical supply, right? All electronic instruments that must be operated with the help of electrical supply. So that's why we are converting non-electrical quantity into electrical quantity. Electrical transducer. Right. So we don't have that much brief explanation. What are the advantages that we are going to discuss here? That's it, right? The first advantages is, so whatever the electrical signal coming out from the transducer, which is easily amplified and easily attenuated. Amplified means maximum, voltage maximum levels are going to be varied. Easily we can vary it and matter. Right? The signals can be easily amplified and attenuated. Right. So what first advantage is the signal that coming out from the transducer that can be easily amplified and attenuated. Next, the second one is mass inertia is less effective. Right. So in this type of transducer doesn't have any rotating part, so that there is no concept of inertia. So if there is no inertia means that is more advantages in order to get the accurate result, right? So these are nothing but losses in a system. So the system which is having a more weight means it's somewhat disturbances will be created in the transducer itself. So the second advantage is mass to inertia ratio. Inertia is a less effective in this type of in transducers, right? And the second one is the frictional errors are less. So there is no mechanical movement now, so there is no chance of frictional errors. Right? There is no chance of frictional errors. And the third one is, so whatever the sensors, so we are used a sensor in order to sense the non-electrical quantity, and that can be sent to the transduction element. So the transduction element which convert a non-electrical quantity into electrical quantity. So that is a process. So whatever the sensor that you are going to use in a transducer, that can be operated remotely. So remote operation with the help of wireless communication, right? So sensors can be operated easily with operated easily remote control through wireless communication. So whatever the sensor that you are going to use in a transducer, that can be operated a remote control mechanism through a wireless communication system. Right? And the third and another advantages is, so whatever the data, whatever the electrical signal that coming out from the transducer, so we can store for a long period with the help of some digital techniques. So that means, so what is a transducer? Which converts non-electrical quantity into electrical quantity. Alright, so whatever the electrical signal that coming out from the transducer, so you can store that electrical energy for a long period of time with the help of some digital techniques. So that is one of the most advantages in a transducer, right? Signal from transducer, so we can store for a long period with some digital techniques. Alright, so whatever the signal that coming out from the transducer, that can be stored for a long period with some digital techniques. And another advantages is, whatever the signal that coming out from the transducer, that we can move for a long distance. Alright, so you can transfer for a long, but suppose if one transducer is there which can generate electrical energy, right, from non-electrical quantity into electrical quantity, but I need to operate another system, another instrument with the help of electrical signal that coming out from this transducer. So I need to transfer this electrical signal for a long distance. It will be very easier, right? So easily transfer the electrical signal for a long distance. Right? So these are the advantages of electrical transducer. I'll explain one more time. So no need to by heart all these things. So just see and analyze, and you just go and write the exam. That's it. So no need to by heart, no need to repeat and repeated study. So that's not good for your external point of view, or else for your gate point of view, or for your IES point of view. So just try to understand the subject. So what is a transducer? What are the parts in a transducer, right? What are the advantages? What are the characteristics of a transducer? So what are the selection factors while choosing your transducer, right? Just analyze, and you should go and write the exam. That's it. No need to by heart, no need to repeated study. It's not good for you, right? Now, what is the advantages of electrical transducer, right? So whatever the signal that coming out from the electrical transducer, which can be easily amplified and attenuated. So easily amplified and easily attenuated, because this is a less quantity signal. That means less stress based signal. That is that coming out from non-electrical to electrical, right? So whatever the mass to inertia ratio, we don't have any mechanical movement in the system. So there are simple two things: as a sensor and the transduction elements. Nothing mechanical in components, but at that input you will get some mechanical input. That's why the mass to inertia ratio is less effective. Alright, there is no mechanical movement. That means there is no frictional errors that can be present in the transducer. And after that, the sensor that can be operated with the help of a remote through a wireless communication system. So that means each and every transducer that it has sensor and a transduction element. So the sensor which sends the non-electrical quantity. So for that sensing, that we require remote control through a wireless communication for any places that you are, right? So you can easily operate through a remote. So no need to go and select your signal strength and all these things, right? And after that, signals that can be from the transducer, we can store for a long period through some digital techniques, right? So that is a very advantageous, right, for our future purposes, right? So we can transfer the signal coming out from the transducer for a long distance, right? These are the more advantages those are presented in a electrical transducer. I hope it's clear, right? Now we'll discuss about different types of a transducer. Different types of a transducer. So basically there are 4 types of a transducer, right? So definitely transducer is nothing but an instrument, so which convert a non-electrical quantity into electrical quantity, right? Which convert one form of energy to another form of energy, right? So there are 4 types. So the first type is first one is so active and passive transducer. Right? Active and passive transducer. And the second one is so primary and secondary transducer. Right? And the third one is analog and digital transducer. Right? So active and passive transducer, primary and secondary transducer, analog and digital transducer. And the fourth one is so electrical transducer and inward transducer. So these are the 4 main categorized in different types of a transducers, right? So what are that? Active and passive transducer, primary and secondary transducer, analog and digital transducer, and inverse transducer. So these are the main main types that we are going to discuss here. But actually in our syllabus we have only active and passive transducers, right? We don't have that much syllabus of primary and secondary transducer, analog and digital transducer, electrical transducer or invert transducer. We don't have that much syllabus. We require active and passive transducer. In that there are few topics like piezoelectric and photodiode. These are the active transducer that we are going to discuss in our syllabus, and more syllabus on a passive transducer, right? I hope it's clear. What are the different types of a transducer? Transducers basically 4 types. Alright, those are active and passive transducer, and primary and secondary transducer, and analog and digital transducer, and electrical transducer, that is nothing but transducer, and invert transducer. I'll just briefly explain what is what. After that we'll go in detail for active and passive transducer, right? I'll explain all the concept. So what is a primary transducer, what is a secondary transducer, what is an analog transducer, what is a digital transducer, what is a about transducer and inverse transducer, what is active and passive briefly. So after that we'll go for in detail what is a passive transducer, what are the different types of passive transducer, what is the active transducer, and all these things, right? I'll explain briefly in this session all the transducer. Now then we'll go for our syllabus component is the active and passive transducer. Right, I'll explain briefly. First part is the first one is active transducer. So you know that active transducer is nothing but active elements. So what is active elements? The elements which always delivers energy, right? It doesn't take electrical energy. You know about network elements, active elements, passive elements. Active elements means it always gives the energy for infinity time. You know about voltage source, current source. So what is the function of voltage source and current source? They'll give the energy to the circuit for infinity time. So whatever the time is. You know about king. King always gives money to the servants. He doesn't take the money from the servants, right? So the king is the active elements, right? So what is the passive elements? Passive elements which always takes the energy. Right, you know about inductance and capacitance. Inductance and capacitance also takes the energy, and also it will give the energy for a particular period of a time. That what I said. Active elements means always gives the energy for infinity time. But inductor and capacitor, you may ask, sir, inductor and capacitor also gives the energy, na? But it will give the energy for a particular period of time. That means inductor, it can store the energy for its capacity. After that it will discharge up to clearance of that capacity, right? For suppose 10 millihenry, it will energize. After that, up to 10 millihenry it will discharge. Then we don't have any inductance, we don't have any capacity, you don't have any capacitance, you don't have any voltage current in it. So that is a difference between active elements and the passive elements. Active elements means these are the elements which gives energy for infinity time. So king and servant. Servant always takes the energy. So the servant is a passive elements. The king is the active elements, right? So those are resistance, inductance, and capacitance, right? Now what is an active transducer? The name itself indicates the active transducer. These type of transducer doesn't require electrical supply for its transduction operation. I hope it's clear. So the active transducer means these type of transducer doesn't require external electrical supply for the operation, for its operation. Means it doesn't require electrical supply for its operation. Whatever the transducer that you are going to take now, so that doesn't require electrical supply. So whatever the output now, whatever the output non-electrical quantity into electrical quantity, that output is sufficient to operate this transducer. I hope it's clear. So what is, I'll discuss in the next session clearly active and passive, because that's our syllabus, right? So I just want to explain briefly, right? So what is active transducer? Active transducer is a transducer. It doesn't require electrical supply for its operation. That means whatever the energy, whatever the voltage that generated in a transducer itself is sufficient to operate this active transducer. What is the example of a thermocouple? Right? Thermocouple is nothing but it doesn't have an electrical supply. So two dissimilar materials that are joined together by varying the temperature, heat will be generated. This heat is converted to electrical energy. So is there any electrical supply to operate this type of transducer? You just have a temperature itself. The temperature, you are giving the change in the temperature, there will be a heat will be generated. That heat is converted to electrical energy. So from that we can calculate the temperature. So temperature or a heat, which is a non-electrical quantity, and whatever the output you are getting electrical is an electrical quantity. So this is like a transducer, thermocouple. So better example. And after one more example is piezoelectric device. So this is very important. We have a syllabus how the piezoelectric transducer will work. So I don't want to explain here. We'll get a brief explain. You will get clear explain in our following session. I don't want to explain here because it is very important concept. So piezoelectric device is a active transducer. This is also doesn't require any electrical supply for its operation. Right, I hope it's clear what is active transducer. It doesn't require any external electrical supply. So what are the examples? Thermocouple, piezoelectric transducer. So these are the active transducer. Now we'll discuss about a passive transducer. Right. So what is a passive transducer? So these type of transducer, it's require external electrical supply for operation of a transducer. That means if a transducer need to operate, it requires electrical supply. So when electrical switch on, only these type of transducers will work. Right? It's require external electrical supply for its operation. Right. So what are the passive transducer? You know the passive element: resistance, inductance, capacitance. This is nothing but whatever the non-electrical quantity that you are getting is nothing but change in these physical components, right? If you want to find the temperature, you just find the value of resistance, or find the value of inductance, find the value of capacitance. So this we can easily convert into electrical energy. So whatever the non-electrical quantity which is converted to electrical quantity. So this quantity you are getting, that is nothing but you are getting changes, right? That's it. We'll discuss briefly. We'll discuss in detail. Alright, so what is a passive transducer? Passive transducer means these type of a transducer, it requires external electrical supply for its operation. So what are the passive transducers? Resistance, inductance and capacitive transducers, right? So the physical parameters will change in order to get the electrical supply. If it is a non-electrical quantity, is a temperature, the variation in the resistance will give the variation in the temperature and it will give the electrical signal. I'll discuss in detail, no doubt about that. Example is nothing but displacement calculations, length, right, resistivity. These are the example for our potentiometric transducer. So these are the example for a passive transducer, right? We'll discuss each and every transducer. Doesn't worry, no need to worry. So what is a passive transducer? It requires external electrical supply to operate to its operation. So that is about a passive transducer. So this is about active and passive transducer, and we'll go for primary transducer and secondary transducer. Primary transducers and secondary transducers. So what is a primary transducer? Primary transducer means we'll get the output in one steps. Right, if you want to find the temperature, right, you'll give the input to the input to the temperature, and transduction element, it will convert directly into electrical energy. So if you want to find the pressure, only one step, so only board and tube is there, it will convert a pressure into electrical signal, right? So only one step will get the result. So those type of transducers we can call it as a primary transducer. But suppose if you have a board and tube, right, this can be used to find the pressure, right? So this is a board and tube. So you are applying a pressure here. you are applying a pressure, and here we will have the meter, electrical meter. So when you apply a pressure, the meter will display the reading. So electrical energy directly you will get. So these type of transducer we can call it as a primary transducer. Right, one step. So pressure converted to electrical energy. Non-electrical quantity is converted to electrical quantity. So how much pressure changing, that much voltage is changing here. At the starting, the pointer at 5 volts, right? So if you apply a pressure, the reading will goes to 10 volts. Right, how much pressure that you are applying means 5 volts of pressure that you are going to apply. So you can easily find out the pressure over this. The non-electrical quantity is converted to electrical quantity. So in one step you are getting the result. So this is called a primary transducer. Right, so one step you get the result. Right, what is a secondary transducer means? In a single step you won't get the result, which is having too many steps, right? For suppose if this is a pressure now, if it is directly connected to the meter, you will directly get the electrical supply. But you don't have this type of mechanism. You just convert it is applied to the potentiometer, right? Right. So when you apply a pressure, what happens? The potentiometer length will be changes. So right, if you are applying a pressure, one spindle is there, it will be changes. It will be changes means change in the resistance will be happen. You can easily calculate the change in resistance. What is the voltage and current? I hope I'll explain in the following classes how the mechanism is there. See, one more time I'll explain. So what is a primary transducer? Directly one step. If you want to find how much pressure, directly one step you'll get the result. So you apply a pressure, there is a meter, and it will display the electrical energy. So what is a secondary transducer means? We are taking too many steps, right? First, the pressure is converted to linear displacement. That means ఎప్పుడైతే నువ్వు ప్రెజర్ని ప్రెస్ చేస్తున్నావో ఏమవుతుంది ఇక్కడ, దిస్ ఈజ్ రెసిస్టెన్స్ నా, దిస్ ఈజ్ ద పొటెన్షియోమీటర్, రైట్? ఎప్పుడైతే ఒక స్పెండిల్ ఉంటుంది, రైట్? ఎప్పుడైతే నువ్వు ప్రెజర్ని ప్రెస్ చేస్తున్నావో ఏమవుతుంది, ఈ స్పెండిల్ మూవ్ అవుతా ఉంటుంది. ఇక్కడికి వచ్చిందంటే this much change in resistance happen now. If change in resistance happen, you can easily find out how much change in the resistance. So that can easily convert it to voltage. So ee voltage ela vachindi by making the pressure. So whatever the voltage that you are getting here is equivalent to the pressure. So you can easily define how much pressure it is. Initially I'll explain per suppose. So I'll explain each and every concept practically, no need to worry, right? So the boat and tube, which is a primary transducer. So whatever the potentiometer that you are using, that is a secondary transducer, right? The primary transducer means one step will get the result. You are directly pressure to displacement, pressure to electrical signal. So how the system is working means pressure is converted to linear displacement, and linear displacement which is converted to electrical signal. So this is one type of transducer and this is one type of transducer. So this is primary and this is secondary. Secondary means two steps, right? So primary transducer means one step will get the result. Secondary means another transducer that we require in order to get the electrical signal. So that is called a secondary transducer. From here the board and tube is a primary transducer, and potentiometer or LVDT, whatever it may be, you can use. So the LVDT, we can call it as a secondary transducer over here. Alright? And the analog and digital transducer. We don't have any syllabus about primary and secondary transducer, analog and digital transducer. Right, what is analog transducer? So whatever the result that you are getting electrical signal now, so that is in analog nature. So the board and tube is there now. So board and tube. So when you apply a pressure, the meter is displayed now. This meter will represent the analog signal. So that is meant if you apply to the CRO, it will decide to convert it to analog signal. So these type of signals that can be operated different types of analog instruments that can be operated with this type of analog electrical signal that coming out from the board and tube. Right, whatever the output that you are getting electrical signal, that is analog nature. right? So the digital transducer means the output in a pulses form. Pulses form means a sawtooth waveform. So whatever the wave, triangle wave, right? So we don't have that much syllabus. You just need to know what is analog transducer, what is a digital transducer. So what is analog transducer? Whatever the output that coming out from the transducer, that is in an analog nature, right? Analog nature, right? So whatever the output that coming out from the transducer, that can be a digital form or pulse form, sawtooth, metric. These are the transducers which convert whatever the physical supply, DC supply, which is converted to square wave, rectangular wave. These are different pulses form, right? So this is about analog and digital transducer. And one more transducer is a transducer and inverse transducer. So what is a transducer? It's a device which converts non-electrical quantity into electrical quantity. So that is about transducer. That is nothing but electrical transducer. So what is the inverse transducer? There is a chance whatever the electrical signal that can be converted to mechanical signal or a non-electrical quantity. So that type of transducer we are calling a inverter transducer. Definitely in lots of power system operations and electronic instrument measurements, we can use these type of transducer at the load end, right? So what is the concept of inverse transducer? It converts electrical quantity into non-electrical quantity. So this is the inverse transducer. So these are the different parts. I explained briefly, right? What are the different types of transducer? Means there are 4 types of transducer: active and passive transducer, primary, secondary transducer, analog, digital transducer, inverse transducer. But we have a syllabus of active and passive transducer only. But I need to explain briefly what about all these types. Active transducer means it doesn't require external electrical supply. What is a passive transducer? It requires electrical supply need to operate. So what are the different types? Resistor, inductor, capacitor. If you want to find the non-electrical quantity, there is a change in resistance, change in the physical parameters, right? Resistance, inductance, capacitor. Change in resistance, you can easily calculate how much voltage is varying. So I'll discuss another issues, right? We'll discuss in the following sessions. And after that, what is a digital analog transducer? Analog whatever the output that coming out from the transducer, that must be an analog nature. So some of the systems, some of the instrument that can be operated with the analog nature, right? So that's why those type of instrument can be used with these type of transducers, right? So what is a digital transducer? Digital transducer which develops, which gives the output in the form of pulses form, digital form, right? And what is a transducer? And convert a non-electrical quantity into electrical quantity, we can call it as a transducer. And what is an inverse transducer? And we require these type of inverse transducer in our power system at the load side. And electrostatic instruments also we are using these type of inverse transducer. The function of inverse transducer is which convert electrical quantity into non-electrical quantity, just a reverse, right? So those type of transducer is a inverse transducer, like motor is it converts electrical energy into mechanical energy. So this is one type of inverse transducer, right? I hope it's clear. In the next session we'll discuss about passive transducer, a neat explanation. I'm requesting you people, you just follow my videos, then only you will understand what is a transducer, what is a concept of instrumentation subject. Thank you for now.